Hello and welcome to another video. In this video we're going to be working on partition equals subset sum. And in this one you're given an integer array nums and you want to return true if you can partition it into two subsets such that the sum of the elements in both subsets is equal and false otherwise. And I think this one I'm going to be making for like a little bit higher level. So if you haven't done DP at all, then I'm going to link the more descriptive one of that. But this one I'm going to assume you know basic DP, you can do basic top-down DP, and then we can go from there, and then we'll have like the optimal solution instead. So for this one, there's like a couple things that are kind of obvious. We can just take the nums and divide by 2, and if that's not possible, then we can return 0, right? Because if you want to partition something into two subsets, those subsets have to equal each other, which means that whatever they equal, right, whatever that number times 2 has to be or this number has to be divisible by 2 essentially, right? Because like if one subset's 11, one subset's 11 is 22 and so on. And if I have a total of like 11, I can't split this equally, or I can't have it, something like this. So we can handle that case quickly. So we can just say like, let's get a total. And we can say like for nums total. Okay, so we can basically say like if the total mod2 does not equal 0, we can just return false immediately. Okay, and then we know also what we want to partition into, right? We basically want to partition to total over 2. So you can say this. So this is a pretty basic top-down DP. Like if you want to do top-down, you basically just like go through the numbers and you just take or not take DP and you see, can I get something equal to this? And if I can get one subset equal to this, then I know whatever I didn't take is equal to this as well, right? This is like pretty easy. So I'm not going to go over that. Instead, we'll be focusing on the bottom up. And so I'm going to be doing more bottom up. There's less videos of that. And yeah, I feel like it's going to be good to get into. So, to quickly recognize, we can even write this in like a comment or something. So yeah, the base case and all that stuff is pretty simple, right? Base case or number equals target, etc. Or we're out of bounds, recursive, take or not take DP. And here, like where are we actually recursing to? So we're going to be recursing to the next index, and we're going to be recursing to some altered target, right, that we're trying to hit. And because the index is just going to increase by 1, we're just going to focus on the space optimized bottom up instead, like straight off the bat. So like I said, I'm assuming you've done this in top down and you want to have like a better solution. And so in that case, we can basically just say, well, because the index keeps going by 1, we can just maintain an array of like all possible targets given an index. And so what's that going to look like? Well, let's just kind of show this. So let's say we have this guy. So in the beginning, we know we can make the number. Let's just look at example 1. We know we can make the number 0. And then like where can we go from there? So if we take the 1, then we can still always make the number we had before because we can choose not to take. So if we take the 1, then we can take our 0 and turn it into a 1. And if we don't take the 1, then we just keep the 0. Okay, what about for a 5? So for a 5, if we take the 5, then we could do 0 plus 5, which is 5, or 1 plus 5, which is 6. Or we can just not take the 5 and it's the same. What about for the 11? So if we take the 11, we'll have 11, 12, 16, and 17. And if we don't take, we'll just leave all the other numbers. And then the last 5, same thing. So we're going to go through all of our numbers and we're going to add a 5 to those. So 5, 6, and you'll have some duplicates here, right, as you could see. So 5, 6, 11, or actually 10, 11, 16, 17, 21, and so on. So we have some duplicates, but essentially these are all numbers you can make, right? So this is all duplicates, yeah. So kind of what we're doing at every stage is basically saying, let's just take let's keep all our old numbers that we could have made, and add num to those, and we can make all those too. So this is going to be kind of our loop. And then at the end of each one of those, we can just say like, did we make the target yet? Did we make the target yet? And if we never made the target, then we're going to return false. And if we did make the target, then we'll return true. And so what's kind of the best thing for this? So in Java, ideally you just want to use an array whenever possible because there's less overhead. So you can use an array instead of a set or any kind of that. So we'll go with that. So we're going to say Boolean array dp equals new Boolean array. And then what's going to be the like the width? So we can just make it target plus 1, right? Anywhere from 0 to target is what we're going to go for. Okay. And then now we're going to loop through all our nums. So, and then, yeah, basically from here, we want to loop to every number. Like we're going to take every number we have and we're going to add nums to that. And so where do we want to loop through? We can loop through everything, and that's totally fine. And the easiest way to do this is just make a new array every time. So at every iteration, we'll just make a new array. And we're going to copy all our old values and then take the old values plus the number. So it's going to be the easiest. You can make some slide optimizations, but it basically ends up being the same thing. So let's do that. So we can say like a Boolean array. And this is kind of like reusable where there might be some way to make this problem in particular a little bit better. But this is kind of a reusable thing that you can use to space optimize everything. So we'll do the same thing. And then we're just going to loop. Once again, you can optimize this part too, but I'm just going to pretend I don't know any, and we're just going to make a generic solution. So I equals 0, I is less than equal to target. All right. So what's the new DP going to look like? So Boolean DP, or actually, yeah, basically like there's kind of going to be two things. So new DP of I is true if the old one is true, or the old one of the number minus the new one we're adding is true, right? So for example, if we're adding 5, if DP of 0 is true, then 5 is true, right? So this is where we have to make sure we don't go out of bounds. So we could say something like, let's see, we can say I is greater than or equal to num, because we don't want to check the old, like for example, if we're trying to add 5, we don't want to see like, is DP of 4 possible here? Because then we would be checking DP of -1. So we want to make sure this part is positive, and then we want to make sure like, is the old DP of whatever we had minus this number true? And if that case, then we can make this number. So yeah, like if in the old DP 1 is true, but then we're adding 5, then DP of 6 would be true in this one. So this is just an and DP of I minus num. Essentially, if the old DP had the number minus this number, if that was true, then this is true. So these are kind of like the two cases. And then we can actually just have so once again, this part's not generic. We can't just check at the end, but we can actually check at the end of each of these loops. Like, did we actually hit the target using this number? If we did, we can just do an early return. So we can say if new DP at target, then we were able to hit the target, so we can just return. And if not, then basically, so the pattern here is you make a new DP. This is a 1D array. This is a 1D array. And then you just set your old one equal to the new one. So you just say new DP. And if if we were never able to hit this, then we can just say return false. You can modify this array in place. You can basically just say like, well, if I'm adding num, I would need to iterate, instead of iterating from like 0 to target, I can iterate from like num to target. And then same kind of thing. Like I don't need to touch any value below num because those are already fine. But then any value above num, these two conditions are going to work. So that'll save you a little bit, but this is basically the same. All right, we can get the wrong answer. Well, let's see what we did wrong. Target DP DPI equals DPI or I minus num. Yeah, I think that's correct. Let's see, actually, so we got false. It should be true. Okay, let's see. DP equals new DP. That part's fine. Oh, did we ever set? Oh, okay. So you need a base case in your DP, right? Like one of these has to be true in the beginning. And so in the beginning, you didn't use any numbers, so DP of 0 will be true, right? You can make 0 without using anything. So this is going to be like our base case. So we can make 0, and then we'll just build on that. Let's see if that's fixed. Okay. And so yeah, this is like the optimal. Let's see if they give you the right stuff here. Target, yep. So yeah, essentially we got rid of a space dimension, and because we're using arrays, it's going to be better. But hopefully this makes sense. This is kind of like the reusable pattern you can use, essentially. You make a one-dimensional DP array, and then you just keep making a new one. So yeah, we can optimize it real quick, just to kind of show you how that would work. So we can get rid of this. We can get rid of this. And yeah, instead of looping from 0 to target, we can actually loop from n to target. Because, yeah, if it was true already, it's fine, and then we only want new numbers. So then this will be this. I believe. Well, let's see. Equals n num. Okay, we got a wrong answer. Alright, so let's just double check. So essentially we want to go from num to less than or equal to target, dpi equals dpi. Yeah, we want to make sure we don't basically like use numbers multiple times. Oh, I see. So I think we have to go backwards. So the problem is, like, let's say the number is like 2, and we used to have 5. So we'll say like, oh, we had 5, but now we might have like 7, and because we have 7, we can have 9 and so on. So the way to fix this is just go the other way, so then we're not including new numbers to like build a chain. So we could say target and go backwards. That way we're not reusing old new numbers. So we can say I is greater than, so the smallest number we can build is num, right? Will just be that'll just be 0 plus the number, so we can do it this way, and then we're not going to be reusing the number. So I think this is like the best you can do. Let's see, like for this problem, but this is not reusable. But yeah, this is like all the optimizations combined essentially for this problem. So yeah, I mean, as far as I know, maybe there's some other thing you could do, but this is like as good as it gets. Okay, cool. So yeah, so this is going to be n times target, which is going to be same as top down, and space will just be target. And so you can see definitely like think about how much, like I feel like this is significantly more difficult than top down, and top down gets you like 90% of the way there. Like we did optimize the dimension, you're not always going to be able to do that. So yeah, so if you're new to DP, I would just take the top down and not do most of this kind of stuff. But if you want to try something more challenging, more fun, you know, you like algorithms type of thing, I do think this is also more impressive. Like if you actually can code this like in an interview, this would be like pretty like a very strong like signal type of thing. Like I doubt many people are going to be able to do this. So yeah, kind of whatever we prefer. But yeah, thanks for watching, and I'll keep making more videos more consistently now.